All right, good day and welcome back to Everything Mathematics. And this year we're going to continue our series, which we would have started last week, which was all on the surds. Today we are to continue with Rule 4, and with no further delay, let's get started. So, Rule 4, well, last week, of course, we started as with Wednesday, looking at the various rules. On Wednesday, we look at the concept with Rule 1. On Thursday, we look at Rule 2. And Friday, we look at Rule 3. So today, we continue with Rule 4 under surds. And Rule 4 states this. Rule 4 states if you have something such as, let's say, A root C plus B, oh, let me put B, not A. Although it doesn't matter, it could be A because it's algebra, but still, let's put a different number. So B, oh yes, and I was very mindful of what I said. I did say a different number even though I put a letter. Because you need to understand I'm only using algebra to represent a generalization, but these will generally be numbers. But even if you have letters, the concept still applies. So notice here, the rule states that if we have something in the fashion of A root C plus B root C, at the ending of the day, our result will be actually A plus B, and root C remains the same. So nothing happens to root C. So of course, granted that A is a number and B will be a number, all we need to do whenever we have a scenario like this is we add the two numbers, or let's call them coefficients. In this case, is like the coefficient of the root of C. We add the numbers and the root of C remains the same. Of course, the same is true if we had it the other way around. Sometimes you may have been subtracting. So let us say you have A root C, but you are taking away B root C. In a case like this, the rule states now that you subtract A from B. And of course, the root C remains the same. What I like to liken this onto is like, think of a quadratic equation or some algebraic expression, right? The root C has to be common, it has to be standard, and only so you could add common things. So if we do in algebra, this could be related to something like, let's say if we have 8x plus, let's say, 4x. In a case like that, it is not uncommon to get a result such as 12x. But really and truly, what is this result saying? In essence, what we're saying, because the x's are common, because the x's is the same unknown, in essence, we add the 8 plus the 4, and the x remains the same. That's how we end up getting 12x. So when it comes to surd, that same concept is pretty much being transferred. So long as what is under the square root is the same, then we keep what's under the square root because it's the same. Whatever it's an unknown, but whatever it is the same. And whatever the coefficient, and I call it coefficient, like when we're dealing with algebra, the coefficient is what is in front of the x, right? So in terms of the surds, the coefficient will be what is in front of the common root. So in this case, it's root C, and here we have root C. And likewise, of course, we just add the A and the B, whatever that would be, and root C remains the same. When dealing with algebra, we add the 8 with the 4, and the x remains the same. So 12x. 8x plus 4x is 12x. Oh, and of course, if we're subtracting, same thing too. If we're subtracting, let me see, let me make some space here. Allow me to erase this. Good. If we're subtracting, it's the same thing we do. So supposing we had something like 10, let's use y, minus, let's say 8y, this will eventually end up being the same as 10 minus 8y. The y remains. Of course, that will give us an answer of 2y. Good. And that's basically what the rule is saying. I'm only using hopefully this algebraic explanation because hopefully we are already versed with algebra and we can relate this to the surds. But now let's do a few examples. So supposing, of course, our keyword here will usually be simplify. So they will oftentimes ask us to simplify. As of next video, you will see some rationalizing taking place. But yeah, supposing they ask us to simplify, let's look at several examples. And example one here, we have one. Number one, supposing I want to simplify something like 4 root 5 plus 6 root 5. And again, notice what is taking place. Notice the rule that is taking place here. Notice that whatever is under the root in these two cases are the same. So according to the rule, we add the coefficients and what's under the root remains the same. So the answer here when we simplify would simply be 10 root 5. And that's all. That's applying rule 4 right here. It's really straightforward, it's very simple. Although honestly, sometimes in a question, it could come up a little disguised because we would not always see it. But this is what the rule is saying. So long as we have a common root here and a common root here, and there's a coefficient in front of them, we can simply add them. And whether you add or subtract, of course, is dependent on this sign here. There I have an addition. That is why I added. Of course, if you have a subtraction, you would have subtracted. Good. Let's do another example. So example number 2. Supposing we have something like 8 root 2 minus 4 root 2. And again, here we notice that there's a common root here, root 2. There's a common root here, root 2. So what the rule says, you operate the coefficients and you leave the root as it is. In this case, notice that there's a subtraction sign here. So we have to take away the 8 from the 4, and that will simply leave us with 4. Because 8 minus 4 is 4, and the answer will be 4 root 2. That's it. That's it. Easy does it, right? Let's do another more intricate example. We're still simplifying, but supposing now they ask us to simplify something such as, so this is number 3, they ask us to simplify something such as this. 3 root 27 plus 4 root 18. Good? So straight away, it's not easy to simplify. Well, not easy, it's not straightforward. Because you look at root 27 and you look at root 18 and then you say, oh no, this is not the same. So, I mean, you cannot add the 8 and the 3 and the 4. I mean, you could if you want, but of course, you'll get it wrong. So in a case like this, we have to do a little manipulation first. We have to do a little simplification inside of the simplification. And I'll tell you in advance, because I did this question beforehand, right? In this case, a matter of fact, let me not jump the gun. In this case, we have to apply, let us apply the other rules first. So here we could go to rule 1. Rule 1 simply states, of course, if you have a square root, you could split it into 2 factors that will still give you what you have there, right? So 3 root 27 is the same as 3, and I'll put it in bracket here to just to denote that the 3 is being multiplied by the root 7, and that's what the 3 is actually doing. So this is the same as 3 into 9 times 3. That's rule 1 here. So I just split the 27 into 9 times 3, and 9 times 3 will still give me 27. So I did not change the question. I just changed the format in what it looks like. Plus, and they have the 4 here now, and I'm doing the same thing with 4. I'm splitting what's inside of the root. So root 18 is actually the same as 9 times 2. Yes, it is still root 18. All I did, I split it. So here I'm applying rule 1. And of course, here is just I do a little cleaning there now. So rule 1 simply states again, if you have these 2 roots like that, it's the same as the root of 1 multiplied by the root of the other. If you're not sure of what I'm doing here, you could go back to last week Wednesday's video. This is where I expounded on rule 1, and hopefully that will expand your understanding even further if you haven't looked at it yet. Good. And then on the other side, we have root 9 times root 2. Good. And here now we could clean it up. This is the same as 3. The square root of 9 is 3. And the square root of 3, since it cannot be simplified, since it's not a perfect square, it will remain as root 3. Good. Plus, on the other side, we'll have 4 into 3 root 2. And the last thing I could possibly do here, let me put it in red because this is my final answer. I distribute the 3 on this side, and on this side, I'll distribute the 4. So here I would end up with 9 root 3 plus 12 root 2. And I wanted to say this earlier, but as I said, I didn't want to jump the gun. Notice in this case, we have 2 different, let's call them variables. We have the variable with 9 root 3, and we have the variable with 12 root 2. Notice now, the root 3 and the root 2 are still not the same. So in a case like this, believe it or not, this is as far as we could go in terms of simplifying. We cannot go further. So no, you cannot go about adding the 9 and the 12, because according to the rule, for you to be able to add the 9 and the 12, what was under the root had to be the same. And in this case, it is not. So this is as far as we go. In the next example, you will see that it's slightly different because it will work out. And I know this again, as I said, because I tried these beforehand. Yeah, when it comes to Surds, I don't do too much guessing because yes, you can never predict what you will end up getting. So I trust it is clear. Let's do one last example, and that should be it for today. So in our final example, we have now number 4, our last one for today. We have 4 root 32, and we are adding that to 6 root 50. And in this case, again, as it is here right now, it's not too explicit. So you cannot see if you could just add us, oh, well, in this case, we added. So you cannot straight away see if you could add the 4 root 32 to the 6 root 50. So here we just have to do a little simplification inside of the simplification and then see what we end up with as roots. So the 4 side of it, the 4 sides of things, we have 4 multiplied into the square root of 16 times 2. 16 times 2 will still give me 32. So I'm good on that side here. On the other side here, I have 6, and that 6 will be multiplied by the root of 25 times 2. Yes? 25 times 2 will still give me 50. So again, this here, what I'm doing inside of the bracket is basically applying rule 1. Of course, at higher levels, we could just skip all this and just jump straight to it because we could see it. But of course, when we're learning, we have to go through the whole process, the whole procedure, right? So this again is the same thing as 4 into root 16 multiplied by root 2 plus 6 all multiplied by root 25 times root 2. When we do this here, we do our maths, ding, 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 we will end up with 4 into the square root of 16 is 4, and the square root of 2, again, that will be an irrational number, so we just leave it like that, root 2, plus, on the other side, we will end up with 6, outside there, of course. The square root of 25, since it's a perfect square, that will be 5, and that 5 will be multiplied by root 2 again, because that will give us an irrational decimal. It will never stop, it will never terminate, and it will not repeat. So you just leave it as root 2. And here now, we expand now. So we distribute the 4, into here, we distribute the 6 into here. And I hope you already see what I'm supposed to get in. I hope you see the pattern that I'm heading towards. Good. So in this case here now, we will end up with 16 root 2 plus, on this side over here, we will end up with 30 root 2. And notice here now, what we have under the roots are common. So what do I do with this? Let me just write my answer on this side over here. I add the coefficient, which would be the 16 and the 30, and the root remains the same. So my final answer here would be 30 plus 16, that's what, 46? 46 root 2. This is your final answer. So this is basically the essence of rule 4. Again, if I should generalize, remember rule 4 simply states that if you're adding or subtracting 2 surds, let's look at it like that. If you're adding or subtracting 2 surds, if what is under the square root is the same, then you could add the coefficient. If what's under the square root, if it's not the same, then you cannot add the coefficient. So here, that is what you would have seen in this example here. Notice that what is under the square root is not the same. So you cannot add the coefficient 9 and 12. But in the last one here, what worked out as a root was the same. We have square root 2, we have square root 2, or root 2, root 2. As a result, you could add the coefficient of 16 and 30. And you would have subtracted, of course, if subtraction was what you were doing. So this will bring us at the ending of today's video. As always, feel free to like, share, and subscribe. Of course, if you have any question, feel free to contact me or leave a question in the comment section. And until the next one, tomorrow, God's willing, we'll be looking at rule 5, and we'll be digging deeper into the whole idea of rationalizing. So until then, you take care.